Okay, so in this video, we're going to talk about chain rule, and then we're going to talk about implicit differentiation, because in order to do implicit differentiation, you need the chain rule. So we utilize the chain rule for composite functions of the form f of g of x. So in order to find the derivative here, we take, the derivative of the outer function, and then we multiply the derivative of the inner function. So let's say we have a function h of x is equal to tangent of x squared plus 3. Well, the derivative h prime of x is equal to, the derivative of tangent is secant squared. So we have secant squared of x squared plus 3. And then we need to multiply this by the derivative of x squared plus 3. So h prime of x would equal, the derivative of x squared plus 3 is 2x. So we have 2x times secant squared x squared plus 3. Let's try one more chain rule problem. So we'll have a function f of x is equal to the natural log of x squared plus x plus 1. So here, let's take the derivative, f prime of x equals, the derivative of ln of x is 1 over x. So now we're going to have 1 over x squared plus x plus 1 times the derivative of x squared plus x plus 1. So f prime of x equals 2x plus 1 divided by x squared plus x plus 1. And that is that. So when we do implicit differentiation, we use implicit differentiation for expressions such as 3x squared times y squared plus 2xy plus, let's say y is equal to 3. Well, here we wouldn't really know how to differentiate this. We could factor out a y, but then we would still have a y left in our expression. So we wouldn't be able to necessarily solve for y. So here, how we would differentiate this, so we need to use the product rule here. So we have 6x times y squared plus 3x squared times the derivative of y squared is 2y, and then you multiply dy dx, or y prime, whatever notation you prefer. And then we have plus, again, we have another product rule. So derivative of the first, so 2y plus 2x. Derivative of y is just 1 dy dx. And then plus derivative of y is just dy dx. And then the derivative of 3 is just 0. Okay, let's clean this up just a bit. So we have 6xy squared plus 6x squared y dy dx plus 2y plus 2x dy dx plus dy dx equals 0. All right, so next, let's subtract the terms that do not contain dy dx. So 6xy squared and 2y to the other side. And then we're also going to factor out a dy dx from what's left. So we have 6x squared y times dy dx plus 2x dy dx plus dy dx is equal to negative 6xy squared minus 2y. And each term on our left-hand side has a dy dx. So we can factor that out. So 6x squared y plus 2x plus 1 is equal to, I'm just going to write it like negative 6xy squared plus 2y. And then to solve, we just divide both sides by this expression. So dy dx equals negative 6xy squared plus 2y, all divided by 6x squared y plus 2x plus 1. Let's do one more problem that involves implicit differentiation. So for example, we have x squared times tangent of y plus y to the 10th power times secant x is equal to 2x. All right, let's do some implicit differentiation here. So we have to apply the chain rule to x squared times tangent of y. So the derivative of the first, that's 2x times tangent y, plus x squared. Now we need to take the derivative of tangent y. The derivative of tangent is secant squared y, and then the derivative of y is just dy dx. Now here we need to do product rule again. So derivative of y to the 10th power is 10 y to the 9th power times dy dx times secant x plus y to the 10th power, and then the derivative of secant x is secant x tangent x, and I'm running out of space here, but the derivative of 2 is just going to be equal to 2. Or the derivative of 2x is equal to 2, so we're going to set all of this equal to 2. All right, let's clean this up a bit. So I'm going to get all my dy dx's on one side and then everything else on the other side. So here we're going to have x squared secant squared y dy dx plus 10 y to the 9th secant x dy dx is equal to 2 minus 2x tangent y. And then we're also going to subtract y to the 10th secant x tangent x. So minus y to the 10th power secant x tangent x. Now that we have our terms of dy dx on the left-hand side, we can factor out a dy dx. X squared secant squared y plus 10y to the 9th power times secant x is equal to 2 minus 2x tangent y minus y to the 10th power secant x tangent x. Now all you have to do is divide. dy dx is equal to 2 minus 2x tangent y minus y to the 10th power secant x tangent x divided by x squared secant squared y plus 10y to the 9th power secant x. That's our answer.